Before you run your HPLC, you need to prepare mobile phase. Here we have 70% methanol and 30% water. This is what we use to bench test our HPLCs before we ship them out. You can use acetonitrile, and there's many other organic mobile phases that you can use depending on your application. It's important to use HPLC grade solvents. These ensure the lifetime of the column and the pump heads are as high as possible. The next step we're going to do is we're going to prime the pump head. What we want to do is pull mobile phase through the solvent delivery line and into the pump head and remove all water, all air before running the system. To do this, what we'll do is open the prime purge valve here a few turns to the left, and then place a Luer lock syringe, several are included in your packing kit, on the prime purge valve and pull backwards. Now, in this case, we've only drawn air, and you may need to repeat this several times to actually get the solvent to start coming out. As solvent starts to come out, you can place it in waste, and then repeat until there's no more air bubbles coming out. Once there's no more air coming into the syringe, you can close the prime purge valve, and the pump is now primed. You should repeat the priming process every day before you operate your BLC-20, or if it has been used in several hours. The final step will be to install the Buck-Chrom software, which comes inside the manual cover. The Buck-Chrom software has to be installed on Windows 98 or newer and must be on a 32-bit system. It can't be installed on 64-bit. Once the installation is complete, you'll be ready to start your HPLC analyses. And on some computer systems, there may be a message that shows that an error occurred during installation, but you can ignore this. In the front cover of the manual, you'll find a sheet that says Buck-Chrom plus factory test configuration with our calibration numbers in it. These numbers need to be loaded into the Buck-Chrom software to calibrate the instrument. So once Buck-Chrom is open, navigate to the Scales and Zeros tab and copy the values from this sheet into the Scales and Zeros boxes here. Once the values have been entered, click the bottom on the button labeled "Click here to read new parameters from the Scales and Zero screen and hardware screens." This will bring up a message saying parameters passed the test, and you can click OK. Then go up to INI file and save INI file as Buck-Sci Micro. It should be the default label, and save. Yes, we want to replace it, and now the software and instrument are all set up for running HPLC analyses. Now that we're ready to run the HPLC, we're going to navigate to the General tab. Here you can set the conditioning time, which is the amount of time that the pump runs before a sample is injected, the separation time, which is the amount of time that the sample actually runs on the column for, the time between data points, which we generally recommend 1 second. The detector maximum will always be 2000 millivolts. You can also set the detector wavelength here. We're going to set it to 254 nanometers today. As you can see, as it's setting the detector wavelength, the screen on the HPLC is actually moving the detector wavelength to 254. Once this reaches 254, it will stop and you'll be ready to move on. If you had a second detector connected, you would check off this Use 2 detectors box. In this case, we don't, so we're going to leave it blank. The next step is to go to Solvent Program tab. We want to make sure that the initial solvent percent for A is always 100% because we're using a BLC-20. If we were using our BLC-20G binary gradient system, this is where you would enter the values for the initial setting of the gradient, and the graph, the table underneath it, would be where you enter the various gradient steps that you want in your program. This is also the screen where you set the flow rate of the pump. Right now it's set to 1 mil per minute. We will leave it at 1 milliliter per minute, but you can change it as high or as low as you would like, down to 0.01 mils per minute, and as high as 10 mils per minute. We're going to navigate back to the General tab now. I'm going to put a conditioning time of 1 minute and a separation time of 15. When you're ready to load the sample, make sure that the valve is turned to the load position and not inject. And with the 100 milliliter flat-tipped syringe, you're going to drop approximately 100 microliters of sample. Obtain about 100 microliters of sample in the syringe, being careful to avoid getting bubbles in the syringe. We're going to insert the syringe into the injection port and depress the plunger all the way down. There's a 20 microliter sample loop inside, so we've now overfilled the sample loop. Any excess waste will come out of one of these tubes and into the waste container here. Leave the syringe in the port until you're ready to inject so that you don't draw the sample back through the sample loop. Now that we're ready to start the run, we're going to press Start Run on the Buck-Chrom software, and then it's going to ask you for a sample file. You can use the default sample file for now. Later on you can create your own file if you'd like. And press Open. At this point the pump will start running at the specified flow rate. As you can see, the pump is running at 1 milliliter per minute. You'll see that the conditioning time is actually counting down here. It's going to go for 1 minute. When that minute has passed, it will ask you for an injection signal. When the conditioning time is up, a message will appear that says waiting for injection pulse from injector. At this point, you should turn the valve from load to inject. This signals to the Buck-Chrom software that you've injected, and you should leave it in the inject position for at least 10 seconds to make sure that the sample loop is cleared out. Once you've waited that amount of time, you can turn the valve back from inject to load and remove the syringe. The HPLC will now acquire data through the Buck-Chrom software, and it will run for the amount of time you specified in the General tab. When the time has elapsed, the pump will automatically shut off, and you will be ready to analyze the data. Now that we've acquired our data and we have a chromatogram, the next step is to identify the peaks of interest. Navigate to the peak ID table, the peak ID tab, and you'll notice we already have 3 components in here. We're going to use these 3 components to label the peaks on the screen. Go down to the box that says right clicks on plot set limit to peak ID table and check it off. Then go back to plot 1, and you're going to go to the left of the first peak of interest to you, and you will right click on the screen. This now sets the time range for the beginning of the first peak. You can click OK now. After the peak, you're going to right click again, and this will set the end time for the peak retention window. You're going to repeat this for all the remaining peaks, where you right click before the peak and then after the peak. These time values are automatically being put in the peak ID table. We're going to go back to the peak ID tab, And you'll see that all of those times have been put in this table here. If you uncheck this box at this point, we can now navigate to peak picking and choose the Pick Peaks on Current Chromatogram button. This now picks all peaks on the chromatogram and will label the ones that correspond to the retention window that you've just identified in the peak ID table. And as you can see on the chromatogram, it has labeled our 3 peaks here. If we go to peak results now, on the peak results tab, it gives us the beginning and end time of each peak, the peak area, the peak maximum, which is also known as peak height, the time of the maximum, which is the peak retention time, the area percent of the entire chromatogram, and if you have a calibration file loaded, it will give you a quantity. This concludes the installation and operation of the BLC-20. For any further technical assistance, please contact us at sales@buckside.com.